Hi, this is Mrs. Rodriguez with another lesson video. Today we're looking at proportional relationships. Now, in our previous video, we were introduced to the concept of a unit rate, and unit rate being a ratio between your x and y units. Okay, so for proportional relationships, that means when you have your x and y, if there is that constant ratio that stays the same no matter what the x's and y's equal, then that means they are proportional to each other. That's a proportional relationship. We can write a proportional relationship as y equals some number times x, okay? Or y equals k times x, because remember, we're using the letter k to stand for unit rate. So before it was all about what's the unit rate and how do you calculate the unit rate for a given situation. Today we're looking at if you're given a table of data of x's and y's, how do you calculate the unit rate from the data? Okay, so don't forget, the unit rate's also called the constant of proportionality, and we are using the letter K to stand for unit rate. And unit rate is always the number you multiply x by to get y. And if it's a true unit rate, then that ratio will stay the same no matter what x or y are. So let's take a look at our first example. Our first example is calories burned while jumping rope. So now we have this graph of data, and it has minutes and calories burned, okay? Now, we want to remember that if it has a unit rate, that means there should be a constant ratio for all of these numbers. Now, when you're looking at a table like this, x is going to be your first set of numbers, y is going to be your second set. If the table is up and down and you have a bunch of numbers, like if this was 0, 1, 2, 3, and this is 0, 11, 22, 33, oops, and then you have 4 and 44. Your first numbers are your x, your second numbers are your y. A good way to remember this is think of the alphabet. In the alphabet, x comes before y, right? W, X, Y, and Z. So X comes before Y in the internet, so it will be your first number in your data table. So now we know what the X and the Y are. So next we have to see, does it have a unit rate? Is there a ratio? So if I'm looking at this table, I know that X is 1, and somehow 1 got changed to 11. Right? It went from 1 minute, 11 calories burned. So what did we have to do to that 1 to make it turn into an 11? Well, if we think about it, we know that 1 times 11 equals 11. That works. Let's go ahead and try it for the other numbers. If this is a proportional relationship, then that means that all of the x's, when you multiply by 11, should give you the y. Okay, so 0 times 11 is 0. Does it work? Yep. Okay, it works for this one. 2 times 11. Does it equal 22? Yep, that works. 3 times 11. Does it equal 33? Yep, that works. And 4 times 11. Does it equal 44? Yep, that works too. So that means our ratio, okay, our ratio x to y is going to be 1 to 11. Another way you could have figured it out is you could remember that our unit rate also equals y divided by x. That's the ratio, right? So we could have said, okay, well, I know that the unit rate always equals y divided by x. Here's my y's. Here's my x's. I'm going to divide them. So let me choose another color. So in this case is, what is 0 divided by 0? Well, going to be 0. 11 divided by 1 equals 11. And that's the answer we got up here is 11. 22 divided by 2 equals 11. Now remember, if these are proportional to each other, if the x and the y are proportional and there is a unit rate, that means when we divide y by x, we should always get the unit rate of 11. So let's try it for 3 and 4. 33 divided by 3. Remember, I'm just taking the y and dividing by the x. And that equals 11. Yep, that works. And then 44 divided by 4, that also equals 11. So it works. And because it works, we know it's a proportional relationship. We know that our ratio is 1 to 11. No matter what x and y are, anytime you divide y by x, you're always going to get 11. And if we were thinking about it in the equation version, y equals, then we know that it's always, no matter what the x is, it's always going to be x times 11. Which we could just write as y equals 11x. Okay? So, as you can see down here, we have calories burned is 11 times some number, which is a ratio, or calories burned equals 11 times time, and that ratio is 1 to 11. Okay? Y equals the calories burned, x equals the time, and the unit rate ends up being 11. So, as we just went over, we could write that as an equation where y equals the k times x, or the unit rate times x. And since the unit rate equals 11, y equals 11x. Now, remember, the unit rate is the only number that stays constant. So when we're writing the equation, we leave y and x alone. We don't put numbers in there for them because they constantly change, right? We went from 0 minutes to 1 minute to 2 minutes to 3 minutes to 4 minutes. The minutes kept going up and the calories burned kept changing and going up. So we just write it as y and x. It's that 11, that unit rate, that stays constant. So we can write the 11 in there. Okay, let's move on to the next example. Is it proportional? A new self-serve frozen yogurt store opened this summer that sells its yogurt at a price based upon the total weight of the yogurt and its toppings in a dish. Each member of Isabel's family weighed his dish, and this is what they found. Determine if the cost is proportional to the weight. Okay, so once again, first number is going to be your x, second number is going to be your y. Okay? So find the ratio between x and y. So we want to know how much does it cost for every 1 ounce of yogurt. If we know how much 1 ounce is, then no matter how many ounces, we can calculate how much it'll cost. So the ratio, or K, equals y divided by x. And in this case, I would use this because in the last one, 22 is pretty obvious that 22 divided by 2 is 11, or 2 times 11 equals 22. With 12.5 and 5, 10 and 4, 5 and 2, 8 and 3.2, it's not going to come as quickly. So we should definitely do the unit rate equals y divided by x. So let's go ahead and do it. For the first one, k equals 5 divided by 12.5, and that equals 0.4. So that means for 1 ounce, okay, for 1 ounce of yogurt, it costs 0.4 or 40 cents. Now, if this is truly a proportional relationship, meaning the ratio stays the same no matter how much ice cream or yogurt you buy, then that means when we solve for the unit rate for each one of these, for the 10, the 5, and the 8 ounces, it should also equal 0.4 an ounce. Okay, so let's try the next one. Let me change colors. So for this one, we have K equals 4 divided by 10, which equals 0.4. Okay, so far so good. We have the same answer. So far we have a unit rate. It's staying the same. It's the same amount being multiplied, right? Okay, so let's try the next one. This one's gonna be, let me grab a new color. K equals 2 divided by 5. So 2 divided by 5 is 0.4. Once again, it works. So far these work. And then we have, last but not least, we have 8 and $3.20. So our unit rate should equal $3.20 divided by 8. So 320 divided by 8 is 0.4. It works. So because these all came out to be the same number, we know that yes, this is a proportional relationship. If I would have divided 4 by 10 and got some different number, even if all the other ones worked, if one doesn't work, then it's not proportional. It's no good. Okay, so let's look at number 1. Find the ratio between X and Y. Okay, well, we just did that. And the ratio, okay, our unit rate is going to be, and remember, that's X to Y. So that's going to equal, for every 1 ounce, you pay 40 cents. So it's 1 to 0.4, or 0.40 if you want to think of it as 40 cents. Does the ratio work for all of the X's and Y's? Yeah, we just calculated it. We got 0.4 or 40 cents. No matter if the weight was 12.5 or 10 or 5 or 8, you still paid 40 cents an ounce. It stayed the same. The price of the yogurt did not change when we changed how much yogurt we were getting. The price of the yogurt stayed the same. It stayed 40 cents an ounce. So, does the ratio work? Absolutely. Is the cost proportional to the weight? Yeah, we have a unit rate. It worked for all the numbers given. The price of the yogurt did not change no matter how much yogurt we bought. So yeah, if you have a unit rate, that means it's proportional. What is the unit rate or the constant of proportionality? So that means, what does K equal? I'm going to go ahead and change colors. So if you'll remember, we can write this as an equation. Y equals whatever X is times some number. So in this case, we know that 5 divided by 12.5 equals 0.4. So that means 12.5 times 0.4 equals 5. 10 times 0.4 equals 4. 5 times 0.4 equals 5. 8 times 0.4 gives you 320. So that constant number, our unit rate, equals 0.4. Okay? Our unit rate equals 0.4. So that means Y will always equal whatever x is times 0.4. So we can write that as 0.4x. Okay? It's whatever y is, it will equal x times 0.4, no matter what x is. And this is important to know because let's say you want to plan a party and you want to buy a lot of yogurt, okay? You're going to buy more than 12.5. Maybe you're going to have 100 people at this party and you want to know how much yogurt is going to cost you if you get yogurt for 100 people. Well, once you have that unit rate, that 40 cents for 1 ounce, then however much ice cream you want to buy, whatever number x, right? No matter how many ounces, your x, you can always calculate your y because you know all you have to do is multiply how many ounces by 0.4. So that's what this is saying. You take how many ounces you want to buy, you multiply it by 0.4, and it will tell you the cost. Okay, so you can also think of it as the cost equals 0.4 times the ounces. Same thing. We just used y for cost and x for ounces. All right, let's take a look at another example. In this example, it says, in the back of a recipe book, a diagram provides easy conversions to use while cooking. So according to this book, 0 cups is 0 ounces, makes sense. A half a cup is equal to 4 ounces. 1 cup is equal to 8 ounces. 1.5 cups is equal to 12 ounces. And 2 cups is equal to 16 ounces. Okay, is the relationship between the cups and ounces proportional? Well, if they are, then that means there should be a unit rate, right? The cups should be multiplied by the same number to get the ounces. Or, remember, the other way you can think about it is, or the unit rate is y divided by x. So if I divide by the x for each one, I should also get the same number. Okay, so let's see if it works. Really quick, my eye is going straight to the 1 and the 8. Okay? Because that's pretty easy. What times 1 gives you 8? 8. What's 8 divided by 1? 8. Okay? So now we have to see if the others work. If all of them, if all the x's multiplied by 8 gives you the answer for y, then it's proportional. If one of them doesn't work, then that means it's not proportional, okay? So you can either divide your y's by the x's, or if you can figure out what times the x gives you the y, that's fine too. So here we go. 16 divided by 2, 8. 12 divided by 1.5 is equal to 8. We already know that 8 divided by 1 is 8. 4 divided by 2. Oh, that's not a 2, sorry. I'm like, that doesn't make sense. It's 4 divided by a half, sorry. So 4 divided by a half is 8. My messy handwriting. Okay, and then 0 divided by 8 is 0, so that works too. Now we look, did we get the same answer when we divided the y's by the x's? And sure enough, we did. We got 8 each and every time. So, yeah, it works. Okay? All right, so is the relationship between cups and ounces proportional? Yes. What is the unit rate or the constant of proportionality? So if we were looking at y equals some mystery number times x, and k is that unit rate, we're looking for what number is being multiplied by x to get y. Well, we said it was 8, so that means the unit rate is 8, right? We said that 8 times x was giving us the y. So that means our unit rate equals 8. Okay, let's take a look at the next one. Alex spent the summer helping out his family's business. He was shopping to earn enough money to buy a new $220 gaming system by the end of the summer. Halfway through the summer, after working 4 weeks, he had earned $112. Alex wonders, if I continue to work and earn money at this rate, will I have enough money to buy the gaming system by the end of summer? To determine if he will earn enough money, he decided to make a table. He entered his total money earned at the end of week 1 and his total money earned at the end of week 4. So, number 1, are Alex's totals earnings proportional to the number of weeks worked? Okay, well, according to this, for week 1, he made $28. So then that would mean, let me switch colors. Week 1, he made $28. Well, if this is my x and this is my y, and we know that the unit rate equals the ratio between x and y, then that means, right, for every 1 x, that means the ratio should be 1 to 28. Okay? Another way of thinking about that is if 1 week is 28, then that means 2 weeks should be 2 times 28. 3 weeks should be 3 times 28. 4 weeks should be 4 times 28. 5 weeks should be 5 times 28. 6 weeks should be 6 times 28, and so on and so forth. Now, this one's a little different because now we're having a table with missing numbers, but that's okay because we can see how much he's supposed to make every week. Okay? Now, if this is truly proportional, then it should work for all the numbers. And you might be thinking, well, how do we know? Well, you'll notice that they gave us 2 sets of data. Week 1 is 28, week 4 is 112. That means if week 4 is the same ratio, that whole thing is proportional. Okay? So that means if 4 times 28 does equal 112, then it works. Every week he makes $28. So let's see, what is 100? Oops. You could either do 4 times 28 and see if it equals 112, or you can do 112 divided by 4 and see if it equals 28. Either way would work. So I'm going to do 4 times 28. And actually, let me go vertical. So I have 28 times 4. And that's 32, carry the 3, 4 times 2 is 8, 9, 10, 11, and lo and behold, it works. So this works. That means, yes, this table is proportional. So we can go in and fill the data. 0 times 28, well, 0 times anything is 0, and that makes sense. If you don't work, you're not going to get paid, right? So for 0 work, you get 0 money. For 1 week, he gets 28. So the second week should be 2 times 28, which is 56. For 3 weeks, it should be 3 times 28, which is 84. We already know for 4 weeks, it's 112. 5 weeks is going to be 140. 6 weeks is going to be 6 times 28, which is 168. And then we have 7 times 28, which is 196, and then 8 times 28, which is 224. All right, so Are Alex's total earnings proportional to the number of weeks worked? Yes. Yes. And how do we know? Because it has the unit rate. And if it has a unit rate, you know it's proportional. What is the unit rate or the constant of proportionality? Remember, unit rate, constant of proportionality, same thing, just different ways of calling it. So our unit rate equals, what did we have to multiply x by each time to get y? 28. So that means our unit rate is 28. Will Alex have enough money to buy the gaming system by week 8? I don't know, let's see. According to the problem, he was hoping to earn enough money to buy a new $220 gaming system. So we have to look at week 8. Did he make enough money, or will he make enough money? And yeah, it looks like he'll actually have $4 extra. So the answer is yes. He will have enough money to buy his gaming system. And that's what unit rates are kind of all about. We want to figure out what unit rates are so that once we know what the ratio is, we can make future calculations, right? If we know how many dollars we're going to get paid for 1 week, then it doesn't matter how many weeks you want to calculate it out to, you can figure out how much money you're actually going to make. Or if you know 1 can of soda is 50 cents, then with that unit rate of 50 cents for every can of soda, it doesn't matter how many cans of soda you can think of buying, you can always figure out how much money it's going to cost. Because however many you want to buy, you just multiply it by 50 cents and that'll tell you how much the total will cost. So unit rates, you know, they're very important, used in everyday lives. And yeah, so there you have it. As always, if you have any questions or need additional assistance, feel free to make an appointment with me for office hours. I hope you have a great day. Bye.